Welcome to the Rural Recharge, a podcast from the Florida Farm Bureau Federation. The Rural Recharge is a guided conversation that allows you to cut through the noise and multitude of information out there. You should be able to trust your sources, which is why we're a platform that comes straight from the source of farmers and ranchers that grow what we eat, wear, and use every day. Our guest joining us today is Dr. Michael Dukes, Director of IFAS Center for Land Use Efficiency. Among the many projects and causes that Dr. Dukes is a part of, he specializes on water use efficiency and irrigation systems. Dr. Dukes and his team are saving millions of gallons of water per year through their systems, all backed by research. Dr. Dukes, thank you for taking your time to be here with us today. It's a pleasure to have you.
Thanks for the invite. It's my pleasure to be here.
Tell us a little bit about yourself.
Okay, well, who am I?
That's right.
So I'm originally from Delaware, grew up on the Delmarva Peninsula. So that's Delaware, Maryland, and Virginia.
Sure.
That's a little piece that sticks out from the mainland. And that's an agricultural area. It's also an area with a lot of tourism and development. And as I was prepping for this conversation, I thought to myself, it's kind of weird. It's almost like a little Florida, really. You know, there's agriculture, there's tourism, and there's development. And really, those are the three big things in Florida that keep everything going. So grew up in this area. It was very much ag then. It's developed more now. And my parents both worked in the ag industry. There's a large poultry industry on the shore. And I grew up within that. I grew up working with my father in that industry. My mom's side of the family are farmers. They were corn, soybeans, some pigs, and chickens, of course, on the Eastern Shore. So that's how I grew up. That's my background. Went to the University of Delaware, undergrad and master's, started in engineering, thought I wanted to design cars. And then I realized that if you're an engineer, you don't design cars. You spend like a year designing one little gear that goes in one piece of the car. And I was like, as a kid, I was like, well, maybe that's not it. And then I got lost at the university. I was a big fish in a small pond back in lower Delaware. Good student, never really had to study. And then when I went to the university, I found out there's a lot of smart people there. So I needed to lock down. And I ended up starting mechanical engineering, went to civil engineering, and then ultimately agricultural engineering is where I found my home. It was it fit my background better. And at that time, as a young person, it just made more sense to me. It's the application of engineering to agriculture. That's how I got started.
Tell us how you end up in Florida and how you end up in such a very specialized area of expertise.
Well, the long and short of it is they offered me a job, but the pathway from Delaware to there was I was finishing up my master's degree and kind of looking around at the private sector consulting engineering, and it wasn't a good time for hiring. So I talked to my major professor, and he had some colleagues he wanted me to talk to for maybe a PhD program. And long story short, I ended up at NC State working with a professor there, working on an agricultural drainage project, where we were looking at buffers to mitigate agricultural runoff into surface waters that ended up into the rivers. That at that time there were several really dramatic fish kills that hit the news. So there was a lot of spotlight on hog lagoons, which are quite a bit of those in North Carolina. So it was all wrapped up around that, and it was a good opportunity for me. So I took it, completed my degree there, and then ended up right here at Florida as an assistant professor in agricultural and biological engineering.
Is your family still involved in agriculture in Delaware?
They're trying to retire, to be honest with you. Yeah. My mom is retired. My father is, like I said, he's trying to retire. He owns his own small business where he works on equipment for the poultry houses. I did a lot of that when I was in high school and college. So like I said, he's trying to retire, but it's a process. He's a really hands-on type of person. He's not a sit in front of the TV type of person. So like I said, he's trying to retire, and I'm encouraging him, maybe you don't have to work so much. My mom's family, they're still in. My cousins are now, they've taken over some of the operations, and they're still conducting agricultural operations, corn, soybeans, some vegetables, and of course, poultry.
Well, a lot of people, when they think of Delaware, Maryland, that area, they don't think of agriculture, but it was a hot topic not too long ago, especially in regard to water. And so some of that, were you involved with at that point, and actually in some of that, and even in school, and then does any of that translate to Florida?
I think to start with your last part first, I think it does translate. Yeah, I grew up in the whole issues with the Chesapeake Bay
That's
and
right.
talking about agricultural runoff and what to do with it. That area, we produce so much poultry manure. What do you do with it?
Right. Sure.
And if you fertilize your crop, doesn't really matter what the crop is. If you fertilize it with that poultry manure to meet nitrogen levels, you've over fertilized with phosphorus just by definition of
Right.
what's in the manure. So that was something the region has struggled with for a long time, decades. And I don't know that they've got it solved. I think they've made some inroads in many ways. Proper storage of the manure so that you
Mhm.
don't get rain that runs through it and
Right.
then it
Sure.
leaches to the groundwater. There was an attempt to turn the manure into pellets,
Hmm.
and so then it could be sold, transported out. I'm not sure that worked out, but there've been a lot of gains. We've learned a lot, and I think it's a lot like our situation in Florida. There's no silver bullet to what we're talking about.
Hmm.
There's a lot of little things we're going to have to do and get better at over time. Hopefully that answers your question.
Well, it's curious
Yeah,
because your background has made you're very specialized in
yeah.
what your area of knowledge, education, research has been directed toward. But it's not uncommon for other places to have very similar, not necessarily the same, but
Hmm.
very similar issues. And, Dr. Dukes, you started off, I mean, Florida is similar. You said,
Hmm.
here we've got similar economies, we have similar issues with development coming in and competing for some resources, et cetera. That's going to be in a lot of the places we are. But to bring that to Florida on a lot larger scale, it seems to be there would be some similarities. That's why I asked, because
Hmm.
to me, that's a very curious thing that
Hmm.
some of us are dealing with problems, and some of those problems are quite, say, broad and common,
Yeah, not uncommon, I would
not
say.
uncommon.
So it's interesting. And a lot of it is so much the same. When I was reflecting on this conversation today, the places I used to go hunt as a kid, those are all housing developments
That's
now.
exactly right.
They were
Yes.
they were farmland.
Hmm.
They were really it was good farmland, and it was on water bodies, so it's very desirable to
Hmm.
develop. And as people age, they sell out. Maybe their kids don't want to do it. Maybe they've gone off and done something else. Yeah, I've seen quite a bit of that. A lot of development. So some of the same things we're seeing here, frankly.
So let's talk about that. So some of the things you're seeing here, what are some of the greatest pressures you see on Florida agriculture?
This is probably bias given the person you're asking the question to, but I do go back to water, and I think about the big picture of this for water. It really is the key to the economic engine of Florida in so many ways. Agriculture. We
Absolutely.
need water
Yes.
for irrigation and just for animal operations. We need clean water. For tourism, we need the same thing. We need water for the tourists who come here. We need clean water. Development, same thing. So it just kind of all hinges on that. Maybe because you asked a water guy, the water guy says water. If you ask someone else, then maybe you get a different answer. But I don't know. It comes back to water. And what I tell people is visitors that are living in Europe and they look at our state to come to, they look at the news. When they see red tide in Pinellas County, they think to themselves, well, maybe I'll go somewhere else this
Sure.
summer. So it really has a broad reaching, and it's such a big issue. Like I said, there's no silver bullet. So I think it's pretty important. And that's on top of all the other issues ag has to deal with, market pressures, labor, so forth and so on.
It's and this water is just not quality, it's also quantity, both
Yes.
of them seeking and being harmonized. We definitely see that across the country. I mean, water's an issue, especially out west. I mean, there's a lack of opportunities for producers to even grow because they don't have the water and they're having to share that with urban development, et cetera. So here we have that, but you're working on a lot of these issues. You're working on some of these resolves within and for not just agriculture, but for the whole of our state and for its citizenry. Tell us about some of the programs that you're working on.
Yep. So I'm the director, Center for Land Use Efficiency. As you said, that center was formed primarily for urban work. Originally,
That's
it
right.
was a Center
Mhm.
for Landscape Conservation Ecology, and that was something that our friends at FNGLA, Florida Nursery Growers and Landscape Association, helped form a number of years ago, and that was really to address what they saw as a threat back in the early 2000s when we had some droughts as soon as there were droughts and then there were water shortage decrees around the state,
right.
watering limitations, plant sales declined.
That's right.
So it's, we have to figure the water out. Back to your question, I've worked in ag. So that I started, one of my first projects here was vegetable irrigation when I got here as assistant professor. And so I've always had that ag piece. And that, I guess in recent years, it's fair to say that has grown a bit. And then this past summer, Dr. Angle and Dr. Gilbert gave me the opportunity to take over leadership of the nutrient management program. That's after, the research years before that. So right now I'm leading that program. That program has been funded by the state. We're entering our fourth year now, and we're requesting money again for that program. And essentially that program was set up to update our fertilizer rate recommendations from IFAS, some of which are almost as old as I am. Now, maybe I get better with age, but our rate recommendations don't.
That's right.
Okay.
That's right.
So it's a much needed thing. We really appreciate support from you all and from the agriculture community to tell the legislature how important this is, because our rates really do need to be updated. We have different ways of farming now. We have different cultivars, different genetics. There's many things have changed in 50 years, and we ought not wait 50 years for the next go around on this. Right. So I'm in charge of that project as a big picture, but there's a lot of people in that project. There's over 60 individuals involved in that project: faculty, postdocs, biological scientists, staff, and so on.
Dr. Dukes, just give us a little more detail there. You've talked about the involvement. There are a lot of people involved. What was the amount of money that was allocated by the state legislature, and what was it specifically for?
Yeah, we've had 4 funding cycles up to date, and it's just over $20 million total.
Mm-hmm.
And so it was dedicated to update the fertilizer rate recommendations. That's kind of broadly, but what really got it kicked off, I think, was our phosphorus rate recommendations, primarily for potato, tomato, snap bean. But certainly we're looking at other crops like citrus. We have sod in the mix, other perennials like blueberry and peaches. So there's a number of crops involved in this. Lettuce down at Belglade. A number of crops we're looking at, largely phosphorus, but there are several with a nitrogen fertilizer component. We're going to update our corn recommendation based on this work. That work was started with FDAC's Office of Ag Water Policy, and then this project allowed us to kind of take it over the finish line.
And a lot of people, we may have people listening that don't even know what fertilizer recommendations are. And take us a little bit even further back, because I think, producers, I understand it because I'm subjected to it, and in the implementation of BMPs, and BMPs are best management practices, which is for an environment, but also have benefits to a producer economically because of the right placement and the right product at the right time, et cetera. Tell us a little bit about the importance of these fertilizers to production and the production needs that are changing, as well as even the recommendations are changing to accommodate that. The reason I ask that, Dr. Dukes, is because I think it needs to all be based in science. And we're not, these are not subjective things, they're very objective. And that's what you're dealing with are very rigid numbers that the public may have at least some idea about what they put on their grass or, maybe their lawn at home, but have no idea what it takes to do in regard to having a productive, profitable agriculture to maintain in the state of Florida.
Yeah, there's a lot to that. So first of all, we are doing, in terms of fertilizer rate recommendations, we're doing over the course of decades. We've done that work similar to other land grant institutions have done for over 100 years. So it's not a new concept. What's different about Florida is that we have the best management practice program through the Florida Department of Agriculture and Consumer Services. And that is the state's plan to meet the water quality goals from agriculture. That's really what it is. So under that matrix, as you know, growers are encouraged to adopt BMPs, sign up, enroll, and adopt the BMPs. And there's a whole process for that. So our rate recommendations are kind of central to the BMPs. That's one of the first things you look at. And I will say, our rate recommendations have been, we have a lot of one number recommendations, which is not inconsistent with what other land grant universities have done with recommendations over the years. Keeping in mind that from that lens, that was never meant to be a speed limit where you get a ticket if you go over that level.
Right.
Okay. it's a guideline. Hey, how much do I need? Well, 250 pounds of nitrogen for that crop. It's a ballpark type of recommendation. It's not meant to mean on your piece of land for this crop year, that's what you need. It was never really meant to mean that. So one of the things we're doing in the rate recommendations updates is we are making sure we acknowledge that variability, because when you have a one number type of recommendation, that implies more precision than there really is with that number, or more certainty than there really is with that number. Okay. I've long said we should have a range. When we do the studies, there's a range that comes out of that study, because you don't measure everything perfectly. I see you smiling, you have a field. Do you get the same yield from every spot in that field?
No,
Of
sure.
course you don't.
Yeah.
It varies for all kinds of reasons. So we're headed down that track where we will acknowledge variability. I really like the idea of yield-based recommendations, because it really is very solid. And then it comes down to you as a grower to say, well, I know the yield potential for my field in whatever way you know it. Maybe you have a combine with a yield monitor. Maybe you've monitored it up with wagons over the years, and this side of this field yields a certain way. But once we give you a matrix of, okay, you need this much nitrogen for this crop based on a yield recommendation, well, you need more for the land that yields more, and you need less for the land that yields less. And that actually saves you money, because if you try to go for that area that has the best yield on your whole field, you're going to apply too much in other areas.
That's right.
So that's kind of my mental model of where I'm coming from with the rates. And we're headed that way with a number of these rate recommendations. So that's going to be a new thing for us.
I think it's really helpful for folks to understand that there has been a point in the past with a number, and that having a wide range definitely gives more ability, I'd say latitude for a producer to actually engage. But we got some differing places in this state, from South Florida in regard to soils and soil types, soil depths. Even on my own field, I can have variations from one end to the other, or from one side to the other, that we need to be able to adapt to. And that's what y'all are doing too, and scientifically, objectively handling some of those recommendations to bring them in compliance where it's actually very reasonable.
It needs to be, as you said, backed by science, really solid, but it's got to make sense.
Absolutely. Yes.
So.
Well, I appreciate that. And I think it's just interesting in regard to those tests. And you have a massive amount of people, 60 people all over the state that are engaged in this. What are they doing to derive those numbers? Just give it a little background how that works.
Sure. So a basic rate study is pretty simple in concept. Now, in the actual carrying out of that project, it's not as simple. But pretty simple in concept. So if you want to know, let's just pick phosphorus. If you want to know what effect phosphorus fertilizer has on your crop, first of all, whatever research that's done needs to be commercially representative.
Absolutely.
Now, for some of our crops, it makes a lot of sense to do that on farm. We've got researchers that are doing that on potato and tomato in South and Central Florida. Our corn group in North Florida, they have plots at one of our research stations. They have a very engaged advisory committee of local growers that come in there, and they're looking at that all season long, and they can give their input pretty much consistently throughout that. And then we take what we learn on those small research plots, and then we go and verify that on the commercial agricultural scale. So those are the really two different types of ways. So what you would do is you want to know, okay, what phosphorus rate do I need? Well, you would try to maintain consistency in every variable except phosphorus, where then we would have home experimental treatments. It could be, you would have maybe a 0, a 50, 100, 150, 200, 250, up to some point where you're pretty sure that, yeah, that's probably too much. You got to find a sweet spot, basically, where I'm drawing in the air here for our podcast listeners, but it's basically, imagine a curve where it goes up and peaks and then it comes down.
Sure.
And so on the x-axis, you would have phosphorus rate. On the y-axis, you would have yield. So you look yield and quality, whatever measures there are for that crop. Interestingly enough, for one of our crops, lettuce, it turns out that the rate of phosphorus, this is a little side story here. The rate of phosphorus influences shelf life. Well, that's a big deal.
That's huge.
You go from 10 days to 15 days on lettuce, and that's
huge.
That's huge. Yeah. And so that's just one little thing that we're learning from this project. And I hope we get to that in this conversation where we talk about, yes, we're laser focused on the rates right now, but there's so many other variables that we're collecting data on with this project, and that I think will benefit agriculture for many years to come as we unlock what's in that data.
So one of them too, and I don't want to get into the weeds or I mean, you talked about a while ago, you wanted to design cars. And I mean, I can imagine as a kid,
I've moved on from that, by the
you
way.
want to just, I mean, you can see these big, nice, whatever cars they are, and then you end up with all these little details. I don't want to get too detailed, but I also understand too that that's part of who we are. And that's what makes this work is the detail part of it is so important, especially for our producers to remain profitable. One of the things that I understand, and I think there's been a lot of research done, is the use of fungal activities in regard to releasing and exercising a plant's ability to be able to absorb phosphorus. We can put phosphorus out, but it's the ability of that plant to absorb it is a whole nother science. And y'all working on some of that as well?
Yeah, there's pieces of that in this project. I have to say something, a little side when you were asking that question. To me, sometimes when I'm learning from the different faculty who are working on this project and the students and the postdocs, I'm listening to these presentations or listening to them talk, and I'm thinking, by the minute, I'm realizing I know less than I thought I knew. You know what I mean? You ever had that feeling?
Absolutely.
It's not a great feeling, but there's so many. That's why I say, and then I sound like a broken record on this, like this to some of my colleagues, but we have to really get a handle on the data that are being developed in this project, because I think some of the data we're collecting today, it could be 3 years from now where we have someone come in and look at it from a different perspective. Maybe it's the microbiome of the soil. There's a lot of interest in that. I don't know, but I do know that we need to get this data in a format and organized in a way that we can utilize it here on out. But to your question, there's all kinds of things like that are going on, because many of our researchers have specialties. They're not. Rate work is kind of the meat and potatoes of science, really. It's not the exciting, the dessert or, the appetizer. It's like, it's just sort of standard. It's necessary. It's important. Another side of it is we have faculty that are collecting data to funnel into crop models so we can better learn from the crop models. We can simulate out scenarios. So in other words, if we have a crop model that we're confident has been field verified, then we can do something like, well, let's do something different with the rates, or maybe something with another rate, or look at different climate types of situations where, we get a bunch of rainy years and some dry, we can do all that in those crop models. And now our researchers are connecting those crop models with our artificial intelligence effort at UF and seeing a lot of benefit there. So I'm very excited for the future of that, but that's a work in progress.
So it's the acquisition of knowledge, the putting of that data into a computer, and that computer's ability to be able to assess, analyze, and extract something from it that could be productive in the future.
Yeah, exactly. Yep.
Let's talk just a little bit too. I mean, I know we will have some producers that are listening to this as well, and some of our farmer friends may have concerns about how we are even testing for phosphorus, especially. Tell us a little bit about Melic and which ones work better. If you've found anything that may be all right, some folks may not even have any idea what we're talking about. But when we go to a field, we test, we pull a soil sample. That sample is sent off to a lab to say that there's X amount of macro element or even micro elements in that soil profile. Here it is. Tell us even the test in regard to what that phosphorus availability is, and have you discovered anything with it that might be encouraging to our producers?
Yes. Let me talk on that, because that is a key part of this project. It's how it started, really.
Yes, sir.
So our soil-based phosphorus test. Let me tell your audience a little bit about that. We'll cover some ground already covered for some of your producers who are experts of this.
No pun intended.
Nevertheless, as you said, yes, the process for phosphorus recommendation, you start by taking a soil test, and there's all kinds of ways to do that, grid it or however you do it. Let's just say that part we understand. We take the phosphorus, the soil test, send it to a lab, and the way the lab, and I'm not a soil chemist, nor did I sleep at a Holiday Inn Express last night. So, but I'll describe this what I think it's layman's terms. That sample, then we've got the soil. So that, how do we know how much phosphorus is in that? Well, what the labs do is they extract it. And so what that means is they wash that soil with a solution of something. There's a water extraction, there's a Malic 1 extraction, there's a Malic 3 extraction, there's some acid extractions. There's all kinds of different soil chemistry types of processes to analyze that soil sample. And so one of those, the Malic 3, named after Dr. Malik.
Mhm.
I didn't know him, but we actually, side story, we just hired a new director of the soils lab, Dr. Franta Mice, and I think he knew him. He talks about him like he knew him. So that's very interesting to hear him talk about what,
Mm.
because you know that not everything gets written down
No.
and archived. And when Dr. Malik developed his test, he developed Malik 3 for a colorimetric analysis. So a machine that basically analyzes the color of that extracted solution. And then there's a calibration table and it says, okay, here's how much phosphorus is in there based on the color.
Right.
But most labs these days are using ICP. I think it's inductively coupled plasma. And I'm getting out on the edge of my skis here on my understanding, but I think it burns the sample up, and then what comes off of that sample, then those signals, those spectra, you can tell what's in the sample. And that process is very convenient for labs because you can get a lot of different parameters or analytes analyzed in that one sample. Anyway, Malik 3, let's go back to Malik 3. So the soil science community has tried to standardize on Malik 3 for a number of years. And so we adopted that 10 plus years ago, maybe 15 years ago, as sort of the standard test. Well, out of this project, one of the things we have learned is the Malik 3 extraction process over extracts. What that means is when we use that extraction, run it through the analytical equipment, we get a number, and it's how many parts per million of phosphorus are in your soil. That number is higher than what's available to the plant.
Right.
That is the short and long of what we have determined on it. Your next question is probably okay, what are you going to do about it? And so there's a number of things we could do that we're looking at. That's very much a work in progress. Like what is the answer is the work in progress. Recalibration of Malik 3. Right now, our limit is 45 parts per million.
Mhm.
If it's above 45 parts per million, our recommendation says don't apply phosphorus fertilizer. Yet we are observing in the field on some of your members'
Mhm.
fields that there is a response. So some phosphorus is needed on some crops some of the time.
That's right.
That's what we know right now.
Mhm.
Now, our task is now to get into the details of, instead of some crops, sometime, find out when it is and really understand that to get a new recommendation. Back to Malik 3. So Malik 3 in our soils, a lot of our soils have been farmed for many, many years, decades.
Right.
So they have a lot of phosphorus in them. And our soils have different pHs, many high pHs in the calcareous soils. We've got iron, aluminum. I think in your area, there's a lot of that.
Mm-hmm.
So that tends to tie the phosphorus up in ways that I'm not sure if it's fair to say we don't fully understand that piece of this puzzle. Okay, we are still working on the soil chemistry part. So as I've been involved in this project for the last 6-7 months, I'm an outsider coming in. I'm not a soil chemist, so I'm telling you what I'm seeing, frankly.
Sure.
And what I see is moving forward in the project, it is important for us by the end of this year, we'll have a handful of crops where we will have an interim recommendation based on the knowledge that we have right now. I don't think we're going to solve the Malik 3 piece of it in that shorter term, but we will have an interim recommendation, much like we did for potato.
That's right.
At the very beginning of this, there's been work on potato for a number of years. So we implemented we didn't have a process for an interim recommendation, which is kind of strange that it never came up, but we didn't. We just had a recommendation or we didn't have a recommendation. Well, what do you do when you have information that points to something you're not 100% sure? You kind of need a temporary, well, let's do this until we find out the full story. And that's what we did. We implemented this process for interim recommendation. And so for potato, there was evidence that we did need some phosphorus, and that interim was implemented as 120 pounds of P2O5, regardless of soil test. So that gave the growers some relief, interjected some reality into the decision-making process, but we know that's not the right answer, the perfect answer. That's not the right answer. And we will get to that. So by the end of this year, we will have a number of interims. And then the idea is that we will have the evidence from this project, the data collection from the fields, that will get us enough information to make a decision on the interim. And then over the next year or so, that work will be published in the scientific literature. And then those PIs will come back to a new term here, the Plant Nutrient Oversight Committee, which is an IFAS committee, PNOC. They'll come back to us and say, okay, here's what the recommendation is after we've gone through the scientific process. I just said a lot there. Did all that come through clear?
To me, it's clear. And I just to summarize it though, from a soil standpoint, a producer standpoint, as well as an environmentally concerned citizenry, that when we do in agriculture, we're taking these soils tests, and you are as well. That's a part of the scientific process. You are taking those soil samples and analyzing them to make sure that you're able to make a proper recommendation that's going to have a range for producers to have some latitude to make good, solid, production-oriented decisions in regard to what would be a good return on investment, but also what's best for the environment and the soil itself. But it has to start off on the right premise. And so what you've just explained is that some of that is still being looked at, and we're grateful for, because I've seen my soil test results come back and I'm like, oh man, I don't need to apply any phosphorus. There's plenty of phosphorus there. Yeah. But when I watch and observe a plant in its growth, all of a sudden it's stunted for a lack of, and you alluded to it earlier, it's volume, the yield that comes out of that plant, but also the quality that comes from it. If that plant does not have available phosphorus there, or nitrogen or potassium, there is a lack that comes from it that has long-lasting issues on the production and profitability of a producer. I appreciate the university's entire look at this, and especially from the testing of mealic and making sure that it's rightful, and then bringing that into the room to where a proper and rightful recommendation is made for our producers, so that that they can stay in business in this state. And a lot of our listeners may be appreciative of that, because then it doesn't end up in houses and doesn't end up in impervious surface or a strip mall or other things that are not agriculture. And it just, to me, it is so important to have a right foundation to build from, and that we're making good, solid scientific decisions. I am grateful for the University of Florida doing this. There is a level of trust that we have in our land grant institution to do the right thing and make the right recommendations. I am grateful that our legislature has understood the value of that, not just to the second largest leg and contributor in regard to this economy, but also to the environment and the value that it has to the taxpayers of this state to invest in this, to make sure that agriculture stays viable. To me, it is outstanding information. And yes, we can get in a little over our head. Any of us can, because I can sit in a room and promise you that I'm not the smartest one in there. That is by far the case. But to some folks, just even a little dip in that deep into the pool, I think is helpful in explaining that this process that you're engaged in. And if not, we can definitely get with you later and have people ask all kinds of questions to have clarification of it.
For sure.
That's right.
Yeah.
But none of us want to read that PNOC report. None of us are going to want to be engaged at some level of, that gets really, really deep. But I think it's important for that, because ultimately a lot of people are going to see and notice this. And water quality is a huge thing. And that comes into the blue-green algae task force and your contribution there as well, and what it means to other parts of our economy, whether it's the residential side of things or our tourism industry. The tourist industry is huge in the state of Florida. And as you alluded to earlier, issues on the coast are a result of some of the things internally in the state, soils and septic tanks and other things going on, that agriculture has a part of that. We are not the silver bullet. If you got rid of agriculture, there goes the problem. Mm-hmm. That is an absolute emphasis that all of us need to realize, that agriculture is a very small portion of this, and we are doing our best to make sure that we are good stewards of what God's given to us, and make sure we don't have to apply more than we need, don't use more water than we need in order to make a productive and quality crop. Explain to us a little bit about the Blue-Green Algae Task Force and your involvement there.
So I had been talking with Dr. Mark Rains. He's a chief science officer in Florida with DEP. And we have been talking for some time. He manages the Blue-Green Algae Task Force meetings and, that kind of thing. And some comments from the Blue-Green Algae Task Force had come up over the course of their meetings, probably over a couple of years, at least a year. To the effect of, why doesn't ag do X, Y, Z? Why can't ag do ABC? Those kinds of comments. these are all esteemed and respected academics in a variety of water fields, but they're not in agriculture, so they don't really understand. So fair questions. And I was talking with Dr. Rains, and I said, why don't we organize a meeting? I don't know if it's him or I think it was him. He came up with the idea because this was coming up, and he and I had been talking about how to educate, Blue Green Algae Task Force leadership at the state. So I said, for the next meeting, maybe we could just bring them to one of our centers. So, of course, we thought of Live Oak, North Florida Research Education Center. They do a great job with outreach. And, I said, let's get them up there. We'll put them on one of the trolleys. We'll go around. They'll talk to the researchers. They'll talk to you about all this, the latest and the greatest high-tech rate research, or maybe it's a technology type of implementation. And so we did that. We organized it, and it was not easiest thing I've ever done to organize that meeting there. But anyway, because it's a properly noticed state meeting, we have to have all that. Anyway, we were able to pull it off. Mark and the DP staff, we were able to do it in the end, and it was really good. They got out there, and I was on one of the trolleys with one of the members, and as we were going around, I could tell she was understanding. Well, they didn't understand concepts like, well, we got a corn grower here. This person is responsible for 10,000 acres of corn. They literally cannot be back to this place physically for weeks. They can't. They just can't. They've got too much going on. They can't do that. They can't baby it. There's a process here. So they understood concepts like that, and it was really a great meeting. And the meeting is it's online. They recorded the presentations of the formal meeting, and I gave a presentation, and I don't know who else gave a presentation. Anyway, I could see them kind of make a turn mentally during that meeting. And they were saying things like, wow, this, these BMPs are great. This is the pathway for agriculture. this is what the state this is the pathway for agriculture. They said, well, we need to help implement those more. Okay, great. And, they also said we need to increase cost share, because some of these things we're asking producers to do. How about a precision fertilizer applicator, a machine? I don't know how many tens or hundreds of thousands of dollars those things are, but expensive and maybe out of the reach for this producer. Well, we need to help them because this is a societal benefit, which is where they finally got to, and they were like, well, we need to double down on cost share. I don't know if they didn't use those words, but you could see they were like, well, we need to spend more cost share, and where BMPs and cost shares don't get us to the water quality goal, it's not on the producer to figure that out. That's the state of Florida, because that's a societal benefit, clean water. And the way they came around was just kind of amazing after just being there for, a couple hours touring around the farm. So I don't know. I left that meeting very optimistic. I'm an optimist, so I'm still optimistic. But yeah, it was great to see them just kind of have that understanding.
It's amazing that education in the right spot in the right time it can be so impactful, and it is. And ignorance is one thing, and a lot of people will operate in the room or in the realm of sound bites and an incomplete understanding of how things function and work. And it is so important to, especially for decision makers, policymakers in the legislature, to have good, solid information, a good foundation for them to work from as well. Just as important it is for the university to have, and the scientists to have a good foundation and understanding of what's coming out of that soil and what to add to. So they need to have a good, solid understanding of what they need, a good foundation to work from and where to invest taxpayer dollars. Yeah. And I appreciate the taking of that time to educate, their willingness to do it, but also your willingness, the willingness of the North Florida Research and Education Center to participate in that, because it is impactful. Even as a grower, sometimes you look at those things, you're like, wow, that is really cool. But then it goes past and into the investment into the producer itself. It is a societal benefit. And it's not that we're taking and reducing to a very precise location, to a very precise amount of nutrient and elemental benefit to that plant. It's just amazing where we are today. But talk to me here just a little bit, Dr. Dukes, about talking to a legislator. Is there anything special that you say to them, or how you relate to them, how you can talk to them that may not have an agricultural background, may not know a lot about soil science, agronomy, but how do you talk to them about the importance of this at their level so they can even relay it to their constituency?
Yeah, I like to try to understand as much as I can about the individual, to maybe understand where they're coming from. If they're coming from an ag background, that just puts me ahead of the game. I don't have to explain maybe so much of the basics, but I guess at the end of the day, I come down on it as agriculture is a tough business, and margins are thin. Things go wrong in a hurry.
That's
You got a
right.
lot of money out there in the ground before anything ever comes back. So so I have a lot of respect for growers in that sense. So try to just explain that to a legislator. It's important. We need to get these rates right so that the growers are not unnecessarily burdened by something that is just not realistic or proven in the real world. But at the same time, we do want to emphasize proper application, like the 4Rs you
That's
mentioned
right.
earlier, like maybe some new technologies that are coming along. North Florida REC, they're working a lot on control release fertilizers,
Okay.
and they're showing a lot of benefit, but we haven't worked the economics on those out on every single crop. So there's things we still need to do. And I think it probably frustrates decision makers to talk to academics sometimes because, everything's a research project and you could research forever. But at some point you have to make a decision. So
Mhm.
that's what I value kind of about extension, because it's like, well, we've got this research product and this data and this paper and what all the other things we've done. Well, let's translate that into usable, applied type of activity. I don't know. I just try to talk to him as a human being. A lot of this to me is kind of common sense, really. And we can't have something so strict. It's up to our decision makers, but if we're going to have something so strict that the grower just can't adopt it, it doesn't really make sense. But at the same time, we are mindful of water quality, and we do that benefits everybody, including the growers. So I don't know. You kind of have to talk to them and see where they're at.
So this upcoming session, we all will have the opportunity to talk to and engage them here 2025 legislative session that we're going to make some requests of them to continue to fund some of these projects, and especially in regard to BMP fertilizer recommendation rates. And it's easy to talk to them about the benefits that it brings to the entire state of Florida, because it does. All of us have got to eat. All of us appreciate open green space and some of the things that we have that agriculture provides, but it takes a good, solid scientific backing to provide that information. And that's why we go to the legislature and ask for those funds for our land grant. Any projects that y'all have this next year, other or in a coupled with, or anything that you're talking about that taxpayers would fund?
Well, we're asking again to continue this project. So thanks for setting me up for that question. But yeah, we're asking again this year to fund that project. It would continue work on all of the perennials because they're so early. When I say perennials, citrus, blueberry, peaches, and that's cold hardy citrus plus citrus down south. Those are they're very early on. When you do something to a plant like that in terms of different fertility rates, you're not going to see the benefit. You're not going to see anything on that for a couple years.
Right.
So those are more like 5 to 6 year projects.
Long projects.
However, we've made good progress on potato, tomato, and bean. And as I said earlier, we have enough information that I expect interim rates by the end of this year. So, our message will be, if I'm asked to go talk to the legislature, will be, here's what you asked us to do. Here's what we've done. We're going to deliver rate recommendations, some interim ones by this year. And then we're going to pursue full recommendations for those within a year, at least within a year. I think actually the corn rate will probably it'll be the final one once we work through the data this year. So that's what I would tell them. Hey, you asked us to do this, we've done this, and we're planning on doing this. Seems like to me it meets the intent of what we were asked to do, and hopefully that will give them enough confidence that yeah, this is a worthwhile investment.
Are you involved in any other water projects outside of BMP
Oh my
fertilizer
gosh,
recognition?
yeah.
Tell us just some of those that are going
Yeah,
on. Just
yeah. So a lot of my career, I actually did a lot of work in residential irrigation.
Mhm.
So still had the ag projects, but there was a time when in the early to mid 2000s where landscape irrigation was a priority in the state. We were growing very fast. We still are. And there were pressures on water supply. And so, as a young faculty member, early career faculty member, this was just there. So as an opportunity, so I grabbed onto that opportunity, and we did a lot of research on smart irrigation controllers. So
Mhm.
that's evapotranspiration, soil moisture based irrigation controllers. When we did that in the early 2000s, it was like people were asking the question, is this even a real thing? And now it
It's common.
they're everywhere.
That's it.
There's over 800 models that are on the EPA WaterSense program has a website where they're a third party tester, and there's over 800 models and now they're just pretty much like standard in many locations, that technology. And you're looking at 20 to 30% savings at least with that
Mhm.
technology. And I get the anecdotal, some friends of mine at work, they're like, yeah, I bought one of those things, and man, it really works good. It forecasted rain, and it delayed and it didn't irrigate, and then it rained, and I'm really happy with it. So yeah, the landscape side, so that's still a big area. We're
Sure it is.
still, I don't know if the growth numbers are still as high as they were, but quite high. We're 23 million people. There's 10 million housing units in Florida. And pretty much all the new construction I see, it's still irrigated landscapes.
That's right.
Now that's
Mhm.
good for our landscape industry,
Sure.
but at the same time, a colleague that he retired now, but he used to work for a big irrigation companies, one of the big ones, manufacturers. And he said one time, I heard him say one time at a talk, he said, one thing that we've done really good in the last 50 years, we've done a good job making it easy to put water on.
Mhm.
Notice he didn't say we've made irrigation more efficient.
No.
So I think there's still some work that could be done in that area, but we've made a lot of progress in the state of Florida. You're seeing all kinds of changes in landscape designs, that
Mhm.
they're smaller, more compact, more drip irrigation, less spring. Just a whole bunch of pieces. Like I said earlier, there's no single
Silver bullet.
thing.
Yeah.
There's a bunch of little things.
I know when I served in the public sector, especially as an elected official, and was dealing with some of the water issues we had. When reuse was a demand we were putting into some of our newer developments, and also groundwater withdrawals were. I mean, we're up, and we had a utility as well that we had to operate and run, and we're permitted by a water management district to pull more water out. And as a grower, as a producer, as a farmer, that concerned me because a lot of times I see those groundwater withdrawals, even though we are using reuse, and that's something we're going to mandate from here forward, especially with new construction. But I still using a lot of groundwater coming out, and we've seen. I know it's cyclical, but we've seen some salinity
Hmm.
issues that
Yeah.
have risen. My question is this, and this is totally off the wall. This is a surprise to you probably, but has there been any research done in regard to desalination for r- the large urban population that we have? I mean, obviously we see that we're surrounded by water on the our border that's salty.
Hmm.
Is there a way to utilize that asset to be able to provide for the urban sector and
Yeah.
their need?
The short answer is yes. The longer answer is it's very expensive. So Tampa Bay Water, that's a regional wholesaler in the
Mhm.
southwest portion of the state. They put in a desal plant 10 years ago, a good while ago. They've had one for quite a while, over a decade, and they very infrequently run that. They have a
They're
big,
expensive.
they have a multifaceted system. So they have multiple reservoirs. They've got a well field, maybe multiple well fields, but I know they have one in Pasco County, and then they have the desal. Well, don't take these numbers to the bank, but the order of magnitude is probably right. I'm told that when they run the desal, it ends up being something like 80% of their energy costs, but it only produces 10 to 20% of the water. So to answer your question, yeah, if you have a nuclear power plant, you connect it to the desal, man,
Yeah,
you're off to the
right.
races. But it's just going to be very energy intensive, because what you're doing with desal is you're pushing water through very fine membranes, so it's a lot of pressure,
Mhm.
thousands of psi, and the salt ions
That's for
are
sure.
left behind. That's how fine it is. So yeah, it's just real expensive. If you're on a nuclear submarine, you're probably not worried
Not
about
a problem.
cost. You just make as much water as you want.
Yeah.
But as far as like doing that, spending that kind of money, and then having people put that on their landscape, that's probably not a wise financial decision. I'm just going to go out on a limb here.
Just economics is the
Yeah.
withholding from it at this point. Well, thank you so much for what you've done and told us today. Well, it's really a pleasure to have you on and to listen. I mean, I could talk hours about this and probably will even after we're done here, but I appreciate you taking time to share some of this with our listening audience. And is there anything you'd like to conclude with? Anything you'd like to give it maybe a last thing to say?
Yeah, I'll just end with, the way I think about that. As I said, I am an optimist, and I think we can tackle these problems. Let's just do it together. This water issue, it's all of us. It's not ag.
That's right.
It's not septic. It's not whatever. It's everything. We're all contributing. So, let's just work together on it.
Well, thank you so much.
Thank
Dr.
you.
Dukes, thank you so much. Have a great day.
Thank you. Appreciate it.
Thank you so much for supporting the Rural Recharge podcast. We hope that you are enjoying these conversations brought to you by farmers for your benefit. While you're here, please consider giving us a rating or a review. It really does help us to continue to share the stories of our Florida farm families and the important impact they have on your community. Thank you, and have a great day.